Okay, let's start. Today we will talk about variables and operators in C language. Variables can have different names and have different types, but one variable represents piece of data. Operators can help you to do some computation. They are predefined in the C libraries. Here are some examples of the variables, like the integer, double procession, floating point, and char. Different variables may occupy different spaces, different amount of spaces, different sizes in the memory. But the size of these variables decided by your computer. On some machine, for example, the LC3, integer is 16 bits. But on other computers, it may have 32 bits. Actually, on most computer, it's 32 bits. You can check the size of each variable by a size of function inside C language. You can find different names to declare any combination of letters, numbers, and underscore can work. And the case matters. So if you capitalize this character, these are two variables, two different variables. But it cannot begin with a number. This is for C, but I believe on Python you can have a more flexible options. So you can only use 31 characters. So here are some examples. Nothing special here, but underscore, you can use the underscore as the first character in a variable name. And these two are the same because when you have more than 31 in the name, the compiler will automatically discard the rest. So only the first 31 character counts. And these are not value variable. This is, you cannot begin with number. You cannot have this character in a variable. You cannot have this character in a variable. You cannot use the data type as the name of the variable or any other reserved keyword as the name of your variable. So here are some examples of different data types. Integer can be positive and negative. You can assign text format number to the integer. These are the floating point. you can write a decimal floating point number like this, or you can write the floating point number in this format. You can even calculate this. So here are some examples of the characters. All of the characters here begin with this character and end with this character. When you have this symbol, this means the following character has a special meaning. It's not a n anymore, it's a new line. And this these two symbol indicate that this is an ASIC. When you declare some variable, it can be global, local. The global variable means you can actually use or access that particular variable anywhere in the program. But the local variable can be only accessed in some regions. And the compiler will manage whether a variable is a global or a local one. And it's not a very good idea to use a lot of global variables because you can accidentally change the value of that variable. And the change on that particular global variable will have some negative impact in other places of your program. So typically, the local variable is used inside functions. And you can only use that particular local variable inside that function. Outside of that function or outside of that region, that local variable cannot be accessed. You can even name another variable by the same name, but that new variable represents a totally new variable, which has nothing to do with the first variable in other function. So outside of all the blocks, you can declare a global variable here. So here is some example. So this is your program. At the beginning, you can include some header. The first variable is this one. This is the global variable. Why this is a global variable? Because you can actually use that variable in this main function. You can even declare a more function in the following spaces. And you can also use this global variable. And these are different local variables. You can change the local variable value inside this function. You can read the value of the variable inside this function. But if you declare another function here, you cannot access local variable because these local variables are only belong to this main function. For example, you can declare another function named main0 here. And in the main0, you can also declare a local variable named is local. And the data is local has nothing to do with this one because they belong to different functions. And inside this function, and in this main0 function, you can also change So if you accidentally change the value of this global variable and some condition inside the second function here is decided by the value of this one, then you may have some error. So that's the reason why it's not a good idea to use too many global variables. We need operators to do the computation, and typically some high-level language provide you a lot of operators. So you can combine the variables and the operators into. So each simple operator here can be translated from many machine instructions. For example, here is a multiplier, multiply operator. And in order to support this operator, LP3 needed to perform a lot of instructions. Because the LC3 does not support this operator. And this operator needs to be done sequentially. Any combination of variables, constants, operators, and the function calls can be called an expression. You can have a type for each expression. Here are some examples of it. So this is a condition. You can check this counter larger or do this stop. This is a square root function. And the value of this one will have you can have more functions, more expressions. A statement is a complete expression. Here are some examples of the statements. And in the C language, each statement is active. And is this. So the meaning of this statement is that you compute multiple one, and then the result is assigned to the Z. You can have some compound groups. And the so-called groups is actually formed by these symbols. In this group, there are two statements. One is a multiplication, the other one is addition. So you need to understand the three things about one operator. The first one is a function. What's the function of one operator? The second one is a precedence, which is the order how the operator line. Here is a operator or statement. So inside this statement, there are three different operators: two multiplication and one addition. So because the multiplication has a higher priority, so you need to combine these two first, and then these two. And the addition has the lowest priority here. So this is why compute this at the end of this statement. And you also need to pay attention to the associativity. For example, here is a statement. You need to compute A minus B first, and then C minus C. Why? Because we need to compute from the left hand to right hand. From left to right. And this is only work for, all the operator has the same priority or has the same precedence. So because we only have a subtraction here, so we do the computation from left to right. So if we have a higher precedence operator, then we need to compute that first. But in this example, we have two multiplication. Among the multiplication, we need start from left to right. After the multiplication, we do the addition. So we also have assignment operator. The assignment operator will change the value of some variable. For example, this is we first use the x value 4. Then the result will be stored exactly here. We need to evaluate this operator from here. To compute this first and then store the result. So for assignment, the result is a value assigned. So typically the value of the right-hand side. Of course, we may have some exceptions, but in the most case, we have this. And assignment associated right. For example, in this element, we need to assign this first, and then assign this value to y. So x gets 3 at 3 first, and then y gets 3 in the second place. Although when we talk about the rule, we write statements like this, but in the real application, do not write something like this. You can write x equals to 3 and then 1. So here is a table to summarize different operators. So you can see that addition and subtraction lower precedence here. For all the other computation here, they have a higher precedence. And here are the associativity. They are the same. And all the operators here involve two variables. So here are some arithmetic expressions. In one arithmetic expression, it may involve one or more than one variable. So multiple variable may have different types. So in one expression, the type of the smaller size will be automatically promoted to a larger type. So, for example, in this case, is an integer, then it will be automatically converted to double because the result here is 2. And here is a derivative. If x is an integer, the result here is also an integer. The fraction part will be discarded. So if you want to have this value, not just the integer, you need to convert to double extension point. And for modular, the result is just a reminder. Besides the arithmetic operator, we also have some logic operator, Boolean algebra. So different bitwise operator or Boolean algebra operator may also have a different precedence here. So you can see that this one has the highest because this is a not operation. And these two have a lower, and this one has a lowest. For the associativity, all the other operators have the same associativity. Only the first one is from right to left. Here are some operators used in the condition. Typically, you can use them in the if. This is mean if x is not 0. And if you use this statement in some if sentence, it means if x is not 0, and if y is not 0, if f is not 0, or if y is not 0. So you need to pay attention to the difference between these operators and these operators. Typically, these three are used in some else. But when you do the computation, Boolean algebra computation, you have to use these. So here are some regional operators. Regional operators also used in the if-else sentence. For example, this symbol indicates whether these two are the same, are equal or not. This symbol indicates whether they are not equal. And we have also some special operators. For example, the plus plus minus minus the plus plus. This means you increase the x value by 1. You decrease the x value. And they have the same function as this, but the order are different. We will talk about the differences in the following slides. So these two indicators means we do the increments and the decrements variable before reading value. So you do the plus plus first and then use the value of x. But these two, you do the increments and decrements after using this value. So if I have x equals to 1, then you can write the value of these two. So here are also some. So E is a 4. Then if I have this, in this one, why? Because I do increment after using this value. First, I use this value. And then I do the increment. After increment, this is the value. And then because I first use this value, so when I use that value is for the value. Again, if I write the expression like this, then I first do the increment, then use it. So when I use the value, so when you use this special operator, this is the operator you really need. So we have some variables here, and here are the values of you can complete these expressions. So let's check them one by one. Because the multiplication and division higher priority, and we have two multiplication and one division here. We need to compute them from left to right. So we compute this first. So we have some symbol like this. And then inside, and then we need to compute the inside of this part. We need to compute this two. And then this one. And the last one we do the addition. First, you need to pick up the parts with the higher precedence. When the fraction has the same precedent, you need to to start from left and then to right. So if you write your own program, you know how to write something like that. Otherwise, you will make some errors. So like the assembler, the compiler also need to know the information associated with the identifiers. So that's the reason why we also need a symbol table here. Inside a symbol table, we have 4 columns. First one is the name, your variable name. Second one is the type, variable type. And then we have the location. There are locations in the memory, and then we have the scope. So you can see that for all the variables local, the scope are only inside this main function. So we can use the stack to store the local variable. The symbol table offset give the distance from the base of the frame. So here are the offset. And the first one is stored in the top of the stack. And all the other, the following, write out the distance of its location to the top. So the R5 in this example holds the graph of the base of the current plane. And similar to the previous function, local variable, when we have a function, we dynamically allocate a memory space and have this dynamic. After we complete this function, we just delay this. It's very similar to the I/O interruption example. So we can dynamically allocate this stack when we invoke this function. We will jump to here and then run the whole function. So similar to the function, we also have a global stack here. Actually, the runtime stack is a part of the global stack. So we put the global variable here. And then we have the runtime stack here. So inside of the runtime stack, we use local variable, but the global data can be also used in the runtime stack. The R5 pointed to the top frame of the stack here. And the R4 register pointed to the global data here. So in these examples, a variable is always stored in the memory. So when we assigning to a variable, the value must be stored to the memory location. But for the real compiler, they will do a lot of optimization. They try to keep more variables inside the register. Why? Because the register is faster. So when the register is faster, when you access those variables, you can have a shorter latency. You can actually write some C code here and then use some compiler to compile the C code into the LC3 assembly codes, and you can run that on the LC3 simulator. So here is an example of the C code. The compiler will build a symbol table. These are the variable names, and these are the data type. This is the output. The location. This is the scope. Only the first one is the global variable. And here is the LC3 assembly code compiled generated by the compiler. I will post the compiler on the canvas. You can also try this yourself. And we also have other two different special operators. For example, this one is the equivalent to this one. So when the destination register, the destination variable is the same as one of the stop variable here, you can use the format. And these operators, this format, these operators, this one. And the last special operator is the three. It has a three input. That's why it's so first, we evaluate this condition, the x. If x is true, then the result is y. Otherwise, the result is a z. So we can use the x as a selection to choose between the y and z. So if x is 1 or 2, we will select 1. Otherwise, we will select z. So in this example, the x is a variable, but you can write a statement as x. For example, whether another variable larger than 0 or not. If e is larger than 0, then we use y, the value of y. Otherwise, we will use the value of e. Any question? So in this lecture, we just talk about simple variable and operators in the C language. And I will post the compiler on Canvas so that you can write your own C code and run C code on this. If no question, we can stop today. Thank you very much.